going to talk about another interesting problem based on sorting algorithms and very specifically talking about merge sort. So what we will do is first we will take a look at the problem statement. We'll figure out an optimized way to solve the problem and then we will implement our logic. So let's take a look at the problem statement. So the problem statement says that you are given an array A of string and here you need to arrange it in lexicographical order using the merge sort algorithm. So I think the problem statement is pretty simple. You have been given an input array which are going to contain a few elements and now you need to print the elements in the lexicographical manner. Okay, that means in a basic sorting arrangement. So if the elements given to you are 3, 4, 2, 1, 5, the output will be 1, 2, 3, 4, 5. The elements simply arranged in an order. And here to do this, you have to use the merge sort algorithm. Okay. So I believe the problem statement is pretty much clear. And if you would have studied about merge sort, you directly just have to go to the implementation and do and complete this problem. All right. But I'll still take a few minutes to quickly reiterate on what merge sort as an algorithm is, what is the heart of this algorithm, and then we will take a look at the implementation. Okay. So what happens in an algorithm called merge sort? That it is based on the concept of divide and conquer. Okay. So divide and conquer is basically a class of problems which is used to solve a wide variety of questions. And merge sort is a very popular, I would say, example of how merge sort as an algorithm works based on divide and conquer. Okay. So here we, as the statement says, works in two ways. First, we divide the problem into smaller problems and then we conquer, okay, or combine those solutions of the smaller problem to get our entire solution. So in this scenario, what the question says is that you need to sort an array. So let's take an example. We have 4, 8, 7, 2, 11, 1 and 3, okay, and these are the elements which needs to be sorted. So what we will do over here is we will first do the process of dividing. Okay, so we will divide this problem into two halves. Okay, so here instead of sorting this entire array, can I say that if the two arrays are sorted, right, two smaller problems are sorted, then I can get the problem for the solution for the bigger problem as well. So here instead of sorting this big array, I will try to sort this array and this array, okay, and recursively keep on moving forward and keep on doing this dividing process. So here I am dividing it into further 4 and 8, 7 and 2. All right, next here also it will be divided similarly 11 and 1 and here for 3. Okay, and then you keep on doing this process till the division is no longer possible. So it is very similar to like a recursion technique where we are trying to reach to the base case. We will stop the division process or the partitioning process until unless it's not possible to go any further. Right? So here we have 4 and here we have 8. Here we have 7. Here we have 2. Here we have 11. Here we have 1 and this 3 goes straight. Okay, so what you can see is that this is very well my base process, correct? Wherein I cannot do the division any further, right? And in other words, we can also say that a single element is always sorted. So the division further is not possible here at all right? So what we will do is at this point, we will start the combining process. So for the combining process, you should know the merge two sorted arrays technique, which is done using 2 pointers. So when you combine two single elements 4 and 8, they can be combined with a single comparison. So when you do 2 and 7, a 2 will come here and a 7 will come here. When you combine this, right, a 1 will come here and a 11 will come here. And this 3 will go as it is. Now try to do the combination of this and this. So the technique is very simple. We apply a 2 pointer technique. One pointer is here, which is P1, and this is P2. Now compare the elements P1 and P2. Individually, remember both the arrays are sorted. Okay. So when you will try to combine, the element at P2 is smaller. So here I have space for 4 elements. So since this is smaller, 2 will come over here and the P2 pointer will move. Now out of P1 and P2, 4 and 7, 4 is smaller. So 4 is taken and P1 moves here. Out of 8 and 7 now, right, I can say that 7 is smaller. So 7 comes and then 8 comes. So this is the merging part of two sorted arrays. Similarly, it happens over here as well. Alright, so here what you will see is that you have P1, you have P2. Now out of 1 and 3, 1 is smaller, so 1 will come here. Out of this, since P1 was chosen, so whatever part you choose the element from, you move that pointer forward. Out of 11 and 3, 3 is smaller, so 3 is picked up and then 11. And now for the final merge process. Okay, what will happen is, again I will take the pointers P1 and I will take the pointers P2. Out of 2 and 1, 1 is smaller, so 1 is picked up. Now P2 is here. 3 and 2, 2 is smaller, so 2 is picked up. Now 4 and 3, 3 is smaller, so 3 is picked up. 4 and 11, 4. 7 and 11, 7. 8 and 11, 8, and then 11. So in the end, what you can see is you started with an unsorted array, right? You kept on doing the divisioning process till it was possible, and then you do the conquer process. So this phase from here to here would be the divide process, okay? And this is basically the conquer / combine process. So this is what effectively merge sort as an algorithm is. And merge sort is actually considered to be one of the most optimized algorithm, because here what we are doing is we are repeatedly solving the problems and dividing it into two halves, right? So when you try to find the overall recurrence relation for this, it comes out to be T of n. You are dividing the problem into two equal halves. So it is T of n by 2 plus the O of n operation for merging. And when you solve this recurrence relation, upon solving, the time complexity comes out to be n log n, which is a very good thing, because this is the complexity which is common for the worst, best, and the average case scenario. Hence, merge sort is a very preferred sorting algorithm whenever we have a sorting use case. Okay, so I hope this helps you to understand. Here we are also implying the technique of merge two sorted arrays, okay, where the two arrays are sorted and you need to take care of the merging process, which is done using the two pointer technique. So I hope that is clear as well to all of you. Okay, now let's quickly go ahead and take a look at the implementation. Okay, first we will take a look at the dividing process and then we will look at the conquer process. Since divide and conquer is very easily done using recursion, so we are going to imply a recursion approach only over here to see the implementation for this logic. Okay, let's go ahead now and take a look at what the implementation would look like. Okay, so what we will do over here is we will start with the merge sort. Okay, we will start with the merge sort process. Just a second. We will start with the merge sort process, and in here we will do this wherein we are given an input array A that needs to be sorted. Okay, so this is there, and Now what we will do is, we have an input array. Now we need to keep on doing the division process till no more the division process is possible. And whenever the length of the array becomes less than 2, the division process is no longer possible, so you return. Otherwise, you do the division right exactly from the middle. So you do this, a dot length by 2. This is the index at which the division will be done. So what is the left part? It will be a dot slice from 0 to middle. And what will be the right part? It will be a dot slide middle to the length of the array. Correct? So this defines my left half. This defines my right half. Okay? And now with this, what we will do is, we simply need to recursively do the merge sort for the left half. Then we need to do the merge sort for the right part. This will return us the sorted left part. This will return us the sorted right part. And then we just need to combine the two answers. So here I will write a merge function which will merge the sorted left and the sorted right part. Okay, that is all I would say the heart of what merge sort as an algorithm is. And since you can see that we are implying the use of recursion over here to do this, so it's pretty obvious to know that here in every question of recursion, we have a base case. We have some amount of self-work that needs to be done. And we also have recursive calls that we need to take care of. Okay. So here you can see that this will be my base case. Okay. This is where I am doing the recursive call, and this is where the self work is happening. So the self work is basically responsible for merging the two sorted regions. Okay, so then we will implement this merge function taking the input array of A and B. Now merge sort as an algorithm requires auxiliary space to combine the two regions. So I will create this. Okay. And in the end, which will be returned and which will be the merged of two arrays. Now we'll go to the length at the end of the length. Okay, and now we are going to push in C based on this condition. We'll consider the elements A of 0 and B of 0. So if B of 0 is smaller, that means this condition is true. We will pick one element from B and put it into A. Otherwise, we will take the element from A and put it in C. Okay. Now, there might be a case, right, where there are some elements left. Let's say this scenario. This is very important for merge to sorted arrays. Let's say here we have 2, 4, 6, and 7. And 1 and 3. Okay, so what will happen is when you will do the merge for both of these, right, it will be P1, P2. First I will pick for P1, okay, and then I will go to P2. Then 2 will be picked and P1 will be here. And then 3 is there, 3 will come. And P2 is come. So what you will see at this point, one of the pointers has reached to the end, correct? But there are still elements left from the second array. Now since here there are some elements left and one array is already ended, it doesn't make any sense to still do any comparison over here. So in that scenario, we simply just copy the elements of one array in here. So whenever you realize that when you are doing the merge process and one of the arrays has already ended, so you just simply pick up all the elements from the other array which still has elements and directly put it. There is no need of comparison at all. Okay. So here what we will do is, till the time if A still has, length there. So what we will do is we will push in A whatever we shift from or remove from B. Shift means removing from the start. Okay. And here, if B dot length still has, that means there are still some elements left in B, we are simply going to do B dot shift. Okay, and then we are going to return. So here we are just calling, we are not calling the function, so let's call as well console.log merge sort. Let's see. Okay, let's see if there's any mistake that we are doing over here. So it says A dot A is an array. Oh, so we are not really passing an array over here, right? So to make it an array, you need to do this. Okay, so we're probably not, so this is the case. Okay, remember this is very important. So you can see now you have all the elements in the correct order. All right, so just to quickly reiterate on what we did, we just defined the cases over here, okay, wherein we are checking whether we are taking the middle element and then just dividing the elements in two half, right, and then recursively doing on this division process. Once no more the division process is possible, then we are going ahead with the merge process. So since we are using JavaScript as a language now, so the merge process is a little bit different and a little bit quicker in here as well. Okay, so what we are doing is, if you have something like this, let's take the same example again, 2, 4, 6, 7, 1 and 3. This is the array A and this is the array B. So when you do A dot shift, okay, it actually removes the element from the start. Similarly, when you do A dot unshift, so this is for adding, this is for deleting. Okay, so you have another array C which is storing your answer. So when you do pick from this, okay, it actually takes away that element itself and the array is just this now. Okay, that is why you're not moving any pointers. You're always just comparing with the very first element, because that element gets removed itself. So the size array B is just this now. All right. Similarly, when you pick 2 over here, this element is removed, like this index altogether is removed and every element is shifted. All right. Similarly, when you add 3, this element is no more existing anymore, or this array itself is no more existing. All right. Whereas when you pick from here, when you have to pick 4, right, you will see that A B dot length is actually equal to 0. But here in this case, A dot length is still existing. So that is why you put 4, 6 and 7. Okay. Remember, since you are using auxiliary space, right, to basically store the merged arrays of the two sorted arrays, that is why whenever you consider the complexity of merge sort as an algorithm, the time complexity is O of n log n, which we have already seen, and the space complexity is O of n. Okay, because if you have two arrays of size n by 2, right, for merging both of them, you would need an auxiliary space of n, right? Then only you will be able to do the merge for both. So this is very important to, I would say, relies about merge sort as an algorithm. So algorithms like merge sort, quick sort, all of them are considered to be very efficient and very optimized algorithms, and each has certain advantages over the other based on the use cases. Okay, so I would highly recommend to go through all of them. There's a separate video on quick sort as well, where we have talked about how quick sort works and similar approach and the way we can implement quick sort as well. Okay, so I hope I was helpful in helping you understand both the questions, right? Feel free to practice more sorting algorithms. They are very, very important for your understanding and very, I would say, popularly asked in interviews as well. So thank you so much for attending this, and I'll see you in the next one. Bye.